Just give it 1 second here. Perfect. Okay. Yep. Thank you everyone for joining. We all know AI and generative AI, or AKA Gen AI, is revolutionizing the world around us, driving innovation and progress in various fields, including healthcare, manufacturing, and art. AI is empowering us to harness data to solve complex problems, while Gen AI is enabling us to create new and original content, from realistic images all the way to captivating novels. Those technologies are really transforming how we live, work, and create, making them among the most compelling advancements of our time. Welcome to Tech Talk with Pratik. I'm Pratik Patel, a technology consultant with Ingram Micro, and your host for today. My mission is, as always, to uncomplicate the latest technologies, and today is no exception. We'll be discussing my favorite topic, artificial intelligence. Everyone, thank you all for joining us. It's crucial that we're all on the same page regarding driving this engine, this AI engine, which represents a great growth opportunity for all of us, our channel partners, VARs, and their customers, plus Lenovo, Ingram Micro, and all the other ecosystem partners. Because not being on the same page could mean it may limit what we can really achieve together in the marketplace. For me, the way we can scale together is to understand how to recognize when something is an AI opportunity, and then identify the best way to deliver a solution. For that reason, we have dedicated today's session to understanding AI. And to do that, we have Rob Rivera, an AI solutions architect with Lenovo. Hi, Rob. How are you doing?
Doing well. Thank you for
Perfect.
that introduction.
Thank you. Yep. Could you please tell us a little bit about yourself?
Sure. My name's Rob Revere. I'm in the AI Center of Excellence at Lenovo. I have a strong engineering background and a strong data science background, and I've worked in various industries for various companies, the like of General Electric and SAS and Infineon and those kinds of things. So hopefully, when we go through this deck, I'd like to make it somewhat informal, although I see we have a lot of people. If you could post questions or raise your hand, and then Pratik's going to keep me honest and interrupt me as I go forward. This is for you guys. So if I say something that doesn't quite make sense, or you need some more further explanation, that's what this is all about.
Perfect. Yeah. Thanks, Rob. Yeah, I was just going to mention that, this event is for you, everyone in the audience, so ask a lot of questions. Definitely take Rob up on that offer, because I've actually worked with him, a couple different events and things like that. Super smart, super, he's got lots of experience, and awesome guy. So definitely ask him questions. He can definitely help with any kind of questions or concerns. Okay, right. Rob, let's dive right in. Can you help my audience understand really that connection between AI and Lenovo in today's technology landscape?
All right, bear with me 1 second while I get set up. Oh, I guess you don't want to do that one, do I? So let me start at the beginning. Okay. So what I'll talk about today is primarily generative AI, but I want to put it in the context of AI overall, and lead into this very complex topic of generative AI. So Lenovo has come out in September timeframe with our position on generative AI. We are advocating a very specific appliance, the SR675 V3. There are two types of accelerators, GPUs. One is the H100 MVL. However, that has a 52-week lead time. So from a practical standpoint, that one doesn't make sense. And the other is another new GPU called the L40S. Both the MVL and the L40S are specifically designed for these very demanding workloads that are generative AI. And I should state here that generative AI consists of several things. One is large language models. You may be familiar with ChatGPT and the like. But there's also other models that deal with voice to text, text to voice, deals with art rendition, deals with all sorts of different types of capabilities, such as cleaning up data or denoising data, that kind of stuff. There's a whole bunch of other techniques. So I just want to make sure that you realize that. So before I go too much further, I want to tell you a little bit about how the practice that I am in is set up. We have broken it down into infrastructure, the AI Center of Excellence, which is where I work. We have a partner ecosystem, which you guys are probably part of. And then we have AI solutions. The one solution I'll talk about is this generative AI solution. However, there are other solutions that can be brought to bear as well. Now, you may have seen this slide, so I won't spend too much time on it. If you've participated in any kind of Lenovo activities, you would have seen something like this. But the whole point is to say that we have 23,000 channel partners. We have partners such as VMware, NetApp, Azure Stack. We have global strategic partner of Intel and NVIDIA. And so the solution I'll talk about in just a second is an NVIDIA solution, is a solution we built in combination with NVIDIA and in combination with VMware. There's some other capabilities around here that you can maybe see your favorite icons. I won't belabor that point too much. I will talk a little bit about training and inferencing and what's the difference between the two and what that means with respect to generative AI. Now, this is an eye chart, but the reason I put this in is I wanted to give a sense of how vast this space is when it comes to our innovators. There are various ones that specialize in generative AI. For instance, I'll highlight Chooch, I should say. They are ones that can do a lot of not only chat GPT and large language models and that kind of stuff, but they also can do quite a bit around computer vision. There's Deep Brain, which is another one I'll highlight. They definitely have a similar kind of capability. They also have interactive avatars that allow, depending upon your customer base, allows for a more pleasant interaction with humans. There's a lot of stuff that's happening in Japan right now, especially when it comes to retail, about having avatars be your first, when you come into a store, being ones that greet you and ones that guide you and those kinds of things. But first, let's get some terminology out of the way. So AI is an overly used term, and a lot of times the term is used not correctly. And so what I did with this slide is I wanted to try to break AI down, which is this large outer bubble, into its components and different words that you may have heard. So artificial intelligence has been around for a very long time. We're talking decades. It's the type of algorithms that are based upon, if this happens and this happens, do that kind of thing. Or it may be based upon that you have a group of data that consists of males and females, and in that group you may have different age ranges and different origins from which people were born, that kind of stuff. And you want to answer questions about these different subsets of data and these different classifications of people. So that's a decision tree. If this happens, then you look down, depending upon, is it a male or female? Are they born in the US or born in EMEA? Those kinds of things, where you build out models, but they're based upon a decisioning process rather than anything else. So that's artificial intelligence. Inside artificial intelligence is machine learning. Machine learning is a set of analytics, a very specific set of analytics that are more based on classic statistics. It may be things such as regression. It may be things such as forecasting. It may be things such as optimization algorithms, things like that are more geared toward machine learning. And then finally, we get to the inner bubble, which is called deep learning. And I'll tell you why in just a second. But inside deep learning, all the models are based upon a very specific modeling architecture. And that architecture is what we call neural nets. Neural nets are based on a concept very similar to the way we think. We have neurons. Those neurons are connected with passageways, and based upon all these interconnections of all the neurons, a decision is made based upon some kind of input. So that analogy now is extrapolated into mathematical models that are called neural nets. The types of examples for neural nets and deep learning specifically in this class will be computer vision, generative AI, and large language models. So let me stop there first. And do we have any questions about terminology before I go a little bit deeper? Okay. So first of all, I want to talk about the landscape of hardware. This again is heavy from a Lenovo perspective. The idea is that we have very small footprint, such as the SE10, that basically is where you would collect data, specifically things like telemetry data. There's then, as you move up the stack, far as size and processing capability, you get into the SE70s, which is another NVIDIA, which has an NVIDIA GPU chip on it. And then you get into your edge servers. And in the case of edge servers in this context, there may be companies that do not want to have their data widely available to anybody. And so they will create air gaps. This also may protect, and we'll talk about something in just a second about responsible AI. This also protects the company from the responses their models get, because it's totally based upon their own data and nothing that would be out in the internet that's the Wild West kind of thing. And then finally, we're talking about data center appliances. In the context what I'm talking about, I told you a little bit ago, we'll be talking about inferencing and training. So training is especially when it comes to generative AI, requires a great deal of compute, a very powerful machine, such as these data center machines. You could do it in the SE 450s or 455s. However, really you're looking at data center machines. And in that case, these models are so large and require so much compute and GPU capability that it really requires a large appliance. I'll define training in a little bit better in a second. Once you have a trained model, and there are models out there that will be part of the solution that are called that are basically something that you can download through the solution through a marketplace, have already been trained. And so now what you do is you take that model and you connect it to the data that's of interest to you. You may have to do a little bit of tweaking of that data, but that's not really training. So the amount of time to value between taking these foundational models, these are large models that have been trained, and getting to something that you can actually start pumping data through is very, very short order. The inferencing piece and these inference models would be happening on these edge servers if you wanted it on-prem. There's some very small data center appliances that you could put it on. And if the model is small enough, such as a computer vision model or machine learning model, then you could even put it out on a gateway, which would be the SE70. All right, any questions about this so far? Okay. So this goes through all that. Let's talk about use cases, and then I'll get a little bit more into definitions, come back to definitions in a second. So we're breaking it down by industry vertical. Manufacturing, retail, health, and finance are the biggest ones and account for the most use cases that are seen today. Now, each of these has its own types of use cases. I'll go through a few of these, but I have more examples as it comes up. Manufacturing, you can look at demand forecasting, you can look at inventory management, you can look at robotics, which is a form of generative AI and not large language models. You can look at any type of visual inspection, whether it's quality, whether it's in the line, looking at paint quality on cars, that kind of stuff, or looking for defects. You look into retail. Retail, the biggest use case right now, again, it's on computer vision, is loss prevention, making sure the inventories, the shelves are stocked, and we could talk about that a little bit. There's also in-store analytics. You can also serve up in retail. Well, you can do this in manufacturing too. You could utilize large language models to help inform the people that are out on the shop floor, or the people that are helping sell, or even as you come into a particular store, you could have this avatar interaction that I was talking about before, where somebody talks to the avatar or types something into the avatar, and then they give responses. Finance is a big area, not only from fraud detection, but also looking at process automation. Personal banking is huge. And this also is an area where not only that large language models can apply. There's regulatory compliance. I'll say one little piece about that as well. I don't know if you guys have seen it recently in the news, but there was a big advance in legal terms where actually documents themselves, legal documents, contract documents, were generated by a large language model, and on the other side of the fence, from the customer standpoint, were negotiated with the customer. Again, everything was computer to computer. You still had to have some lawyers that looked at the final outcome, but all the routine efforts were now taken away from the lawyers and put to the actual analytic capabilities of large language models. And then healthcare. Healthcare is a huge area, and I'll talk about that a little bit in a second.
Hey, Rob, I did have
Yeah.
one question on that. I know the legal example you just provided there, this sounds like an awesome use case, but I know there's that hallucination effect where it could just give you wrong data and just thinks it's right. What
Yes.
are your thoughts on that?
Okay, I'm going to talk about that in a minute, but the answer to that is always a risk. And that's the reason why humans will always be in the loop on any of these things, to do sanity checks on what results. I'll talk a little bit about hallucination in just a second, though. Any other questions before I go through a couple more use cases?
No more questions in the chat, but I'm having a side conversation, sorry, in the chat. I asked, are clients really asking about AI? And I got a few responses saying yes. I think there's some education that can be provided for the clients to have them understand better. And one response I even got says they're wanting to automate. So I think we're in line with what we're talking about today.
Good. And I'll go one step further. This gets back into that definition of AI. So one of the things that you would need to do when you're talking to your customers is try to tease at a little bit more about what do they really mean by that. If you can get a better description of the use case or the problems they're having, then you can classify this better as whether it's AI, whether it's machine learning, whether it's deep learning, and even in deep learning, is it computer vision, or is it generative AI, or is it large language models? And that's actually the reason why I'm going through a bunch of these use cases, because I'm hoping that this will plant some seeds in your head to give you an idea of the kinds of things you would want to be looking for, and phrases when a customer basically says, I have this problem, how can I solve it? I have insurance here, again, claim automation, personalized marketing campaigns. This one's kind of interesting because you can also, whether it's insurance or something else, you can also do email blasts that are automatically generated for you. Again, this is based on large language models. You can have conversations with particular clients or customers. Again, most of that's being driven by chat bots and the like. Again, narrowing them down, say through a funnel, if you will, till they get to the point where your expertise comes into play and you can further refine that messaging with them. We already talked about the concierge banking. We talked about nefarious pattern recognition. Simulation is an interesting one that is part of generative AI. And in this case, you can take macroeconomic variables along with risk analysis and come up with what you would potentially expect the outcome to be. Now, there's a lot of, day trading that goes on. This is not quite that, because they have a lot of algorithms that are built into the trading desk. But this is is more about, here's a pattern that we expect in the near future. How should we respond? So it's not like a day trading kind of thing. Manufacturing, I alluded to quite a few things. I want to talk about repair manuals and service bulletins and warranty claims. If you're on the shop floor and you're manufacturing a widget that has multiple steps and has very sophisticated machinery, most of the time people don't know that machine's in and out, and especially don't know about all the warranties that could be being generated by the parts you're producing. They definitely may not know about any kind of service that's getting ready to come up. And so by allowing the models themselves, and we're talking about large language models in this context, to go in and air quotes, read all this data, you can now service up to the actual people on the shop floor, the people that are interacting with the machines, what they should do next or what they should be aware of. So it democratizes data and it democratizes these models. Life science, this one is very exciting for us from a humanities standpoint. Not only do you have advances in imaging, but you also have looking at DNA itself and the proteins that are associated with DNA, and modeling that before you actually do experiments so that it improves drug therapies, but it also improves genomic types of solutions. And then I have all sorts of other things that are across the board, things such as creating new original art, creating videos, actually creating computer code, which is something I really like. Cybersecurity, anomaly detection, malware detection, intrusion, all that is in this sort of big bucket of generative AI. Now, before I go to the next stage, I wanted to see if there are any questions about the use cases.
No questions about the use cases specifically in the chat, but there was a question about, will you be sharing this PowerPoint?
I will be able to, yes, the short answer is yes. I have to pare it down a little bit and validate. There's a couple of slides that I need to just get permission again, but yes, the short answer is yes.
Perfect. Yeah. So what I'll do is I'll actually be sending out a follow-up, so that'll be part of that package. Thank you.
That would be perfect. Now it looks like I've inadvertently removed a slide that I didn't want to remove. And I am so sorry because I did this right before. So I'm going to talk to it. So this has to do with responsible AI. And as part of that, what does that mean? That means that I can go in right now and let's take ChatGPT, for instance, which was developed by Microsoft. And if you use Bing, you are actually behind the hood using ChatGPT. So I can go in and I can enter a phrase, whatever phrase I want, and it goes throughout every document, every image, every clip that's on the internet, and it comes back with response that it thinks, and it being the model thinks, is appropriate. There are a couple of problems with this. The first is that means that vulgarity can come back. That means racism and sexism can come back. That means distorted opinions can come back. All those kinds of things need to be addressed. And I'll talk about that a little bit. So I'm still under the umbrella of responsible AI. Now let's talk about hallucination, which again is an area. So what is hallucination? Let's say that I'm enter a phrase that says, how are the hurricanes doing? And I don't say anything more than that. So if you're in my area, which is in the Raleigh-Durham area, we have a professional hockey team, and they are known as the Hurricanes. So if my question was really geared toward this hockey team, as opposed to hurricanes that have hit this past season, then I can get responses back that are more geared to what were the named hurricane storms this season? How much damage did they do? What I really meant is, how are the Hurricanes hockey team doing? So that's an example of hallucination. And it very well may be I start down one path, and let's say this time I put, how are the Hurricanes hockey team doing? I get responses and I ask more and more questions about it. But then suddenly the algorithm gets confused and jumps over to the more commonly referred to topic of hurricanes, and it flips now to basically hurricane forecasting. So again, though, that's kind of thing, all these things can be mitigated. And the state of our society now is, most governments, including the US government, I don't know if all this is based in the US, is that the policies have not kept up with the technology. Now, there was, and I'm going to focus on the US now, there was recently, within the last month or so, where the administration came out and said that they want to partner with the Googles of the world, the Microsofts, the Facebooks, all those of the world, and they want to come up with some way to make it clear to the consumer of these models that something is being generated versus somebody saying something behind, that a human is actually giving a response. And so there's this big push now to have watermarking. And in that case, it may be electronic watermarking rather than, watermarking that you would see on a legal document or whatnot. But there are strategies where they are really trying to address, because there is a great deal of fear that, and this is justified fear, that we've gotten to the point technologically where we can answer some things we haven't been able to answer in the past, where we can look at things and look at data and information in a way that we've never been able. And so we will get back what appears to be a reasonable response, but it could have all these problems that I just mentioned. Now, I want to reiterate something I said before. Let's say you're talking to a company, and especially if they want to make sure that what's returned is not vulgarity, is nothing to do with any type of derogatory comments and that kind of stuff. So a company can basically connect these foundational models, and I'll talk a little bit more about those in a second, to their own data, and that way it controls the universe of data that these models would run against. So any questions about hallucination, responsible AI, or anything in that context, or for that matter, anything we've discussed thus far? Okay. So let's talk now a little bit more about large language models. Now, I did already mention this and did arm waving, but the point is that Lenovo has the takeaway from this slide would be, Lenovo has an AI innovators group that we can work in conjunction with them and with you and with your customers to come up with solutions that make sense. We talked about responsible AI already. And then the AI Center of Excellence, I want to talk about that a little bit more. The practice that I am in is actually in the Center of Excellence. So you have people on staff that can help build out models from scratch if you want. We can help set up POCs. We can even, we have our own lab that basically has the hardware that I'm getting ready to show you. So we can take a customer's data, desensitize it so that there's no confidentiality issues, and run models and show how it would work in our own environment. But also in the lab, we have, depending upon the availability of hardware, we can loan out hardware to a given customer and allow them to take it internally, connect it to their own legacy system data and their own, the rest of their systems. Of course, we can help with that too, and run everything within their own firewall. All right, let's talk a little bit more about the types of generative AI models. Now I have chatbot here, and tools. But really, this slide I meant to not only cover chatbot, but to cover the big swim lanes of kinds of capabilities that generative AI can do. We already mentioned where it can take text, these could be blogs and emails, and it can convert it into new original content. There's image data where you can basically take an image and like if you see in the lower right, a plug for Coca-Cola, but basically images of an astronaut and images of a Coke bottle. Those were just the JPEGs of them were presented to this software, and then it can convert it into its own art form. And this is a rendition from the actual code itself. Video, voice, and music. All of these, you can take certain snippets of each of these, and the algorithm itself can create brand new information that's in these various forms. Text, I already talked about a little bit, and the models that I want to talk about would be this DALL-E 2, Deep Brain, of course, is an example of an ISV that does this. And I think that's pretty much all I wanted to do on this particular slide. Any questions about that? All right. Now we'll move into the solution that Lenovo has worked out with NVIDIA and VMware. The whole idea behind this solution is that it's a gray box. By gray, I mean it has all the moving pieces. You can look in, you can see them, but they've already been connected and optimized for all the components. And this solution can then be deployed to a customer's environment, put into their ecosystem of data. There's some things that would need to happen, can be integrated with applications that they already have and new applications, and basically allow you to have pre-trained models, foundational models, available to you to download from this solution. And there are two variants of it. One is a virtualized environment variant, and the other is a bare metal. This shows a slide on a little bit more on the large language models. So these are the big open source large language models that are out there. And each of these model types do different things based upon use cases. You'll see some of these are actually have the same capabilities and then some. So let me do the two I usually pick on are ChatGPT, because that's widely known. And this is one where if depending upon how you set up your UI, you enter a phrase, it goes out and searches everywhere that it has access to data, and it returns the most relevant information and gives you the hyperlinks to the actual documentation for that. Contrast that now to Bloom. Again, all this is called large language models, just different types of models. In the case of Bloom, Bloom is very good at translations. It can also do very well at creating brand new computer code to solve a particular problem. So that shows you some examples of two different types of models. There's Llama, there's Lambda 2, there's DALL-E. DALL-E again was more for the artistic piece and rendition of art forms and taking various types of images and changing those. And then Lambda 2 is very good for conversational dialogue. So all these models along the top here are what are called foundational models. And what does that mean? That means that a company, one of these big boys that you see below, has gone out, has a lot of compute power, and has spent months training these new models based upon a very large representative sample of data. So they have the models finalized and they're then loaded so that into some kind of delivery mechanism, such as a library or whatnot. so that a customer can then download them and attach them to their own data. So the key takeaway here is they're foundational models that somebody has already built for you, that you take, combine with your data. There's a little bit of effort that has to go into that. And now you have a model that is used for inferencing. The difference between training and inferencing is that training is where you either start from scratch or you may have an idea of what it looks like. And there's a very specific statistical methodology that you go through to find the best model that represents that data set that you want. Once you figure that out, and that's what the data scientists do, they then have a piece of code. So the trained model, all it is a very complex piece of code that then gets deployed into a production setting. That piece of code now, as soon as you deploy it, becomes an inference model. In other words, it has new data coming into it, and then it gives some kind of output. It could do a probability of fail. It could give you a phrase. It could give you a new image. Whatever the output is that's appropriate to that originally trained model. Once it's in production, it becomes an inference model. And that's what most customers are looking at. That inference model requires is not as demanding on the CPU and the GPU because it's already gone through to create this really massive amount of code. All it really requires now is something that allows for the computations of this algorithm to take place. So does that make sense between training and inferencing, between the model types that are large language and what they can do? Any questions about that?
Nothing in the chat at the moment.
Okay. All right. This actually was what I was looking for a second ago when I'd find it. This has to do with responsible AI. It's pretty much what I've already said. One thing I didn't mention about plagiarism is a big problem. Dealing with ownership, the raising of ethical issues, all that kind of stuff. And I think the question was when I was talking about the legal documents and contracts being reviewed, there's absolutely a risk there. And all the risks are just like you see here. They could create a contract that makes no sense from either the customer standpoint or whoever's selling it. And it looked perfectly legitimate document. However, it needs somebody with the expertise to come back and say, no, this is really not what we need. All right. Finally, I'm going to talk about the solution that we offer. So everything on the right of this slide is this gray box that I've been talking about. If I start at the bottom and work my way up, you'll see that the classic hardware layer is something that if you've been selling Lenovo products for a while is what you would see and have seen. In this case, we're looking at the SR675 V3 as the appliance of choice. Certainly other appliances can be utilized. However, again, for this type of workload, this is what we advise. I already mentioned about the L40S. xClarity is a Lenovo piece of software, but it really is responsible for managing this bottom layer, if you will. Now, as I go up, in the case of a bare metal, the boxes that are in gray is what's assumed that the customer already has or can get to be put in place. The thing here to take away is containerization. Containerization is very big, and in most larger organizations, IT has made a decision about how they want to utilize containers and how they want to deploy containers and all those kinds of things. Now, the one other thing that I will highlight is for the software layer from NVIDIA, which is on the green box on top of the gray boxes, it only supports two types of operating system. One is Red Hat Enterprise Linux or the latest version of Ubuntu. So that's the only really restriction that you have when using this particular solution. Now, if I get into the software layer, what I want to talk about is I want to talk about what you actually get as part of this solution when it comes to the modeling pieces. So a component of this solution is NVIDIA AI Enterprise. And there are two frameworks. One is NeMo and one is Riva. If you're doing voice to text or text to voice, then you need Riva. With NVIDIA AI Enterprise comes NeMo. And so you would basically, in the case I just illustrated, you would tack on top of NeMo this Riva framework. What do you get out of that? You get infrastructure that's optimized for these foundational models. You get this large library of foundational models that the user can then select from and download. They've already been trained, they've been optimized for the hardware, and they've been optimized for the GPUs, all those good kinds of things. You can also, it's also set up so that if you're writing your own Python code or you're using any type of sort of standard language that's built around these kinds of models, you can integrate with this system already. And there's already capabilities around the front end of this solution that allow you to actually write code in that language inside the solution. Then there's, as I move to the middle box here, then there's all sorts of things that are related to the data science piece of this. The setting up of deployment of those models we talked about a little bit before, the setting up of training at scale, all those kinds of things that take the models that are foundational models and allows you to deploy it in your own environment. And then you get down into sort of the mechanics of things where it allows you to run your GPUs, use Kubernetes, which is a container management system. It allows you to optimize your networks, all those good kinds of things. And then finally, as part of that software, you get NVIDIA Cluster Manager. Again, this is all about optimizing the operation. And everything that you see on this side, it is per node. So the stack for each of the nodes that you purchase, everything that's in here would be laid down. I want to talk about the application layer a little bit. Now, this is something that the applications chosen depend upon the use case and whether the customer wants them or not. Now, I'm going to highlight two. One is Databricks ML Flow, and the other is Kubeflow. Databricks is a leader when it comes to making a data lakehouse and using a Delta Lake construct in that lakehouse. And so what does that mean? There's a very specific way when you get out of when you are focused on analytics, there's a very specific way you want to structure your data. And it doesn't mean that you're replicating the data necessarily, but you may have a ERP system that has several tables in it that you don't want to bring the entire ERP system down. But if you're doing particular types of models for particular types of use cases, you may want to bring, a few of these data sets down and put them in this data lakehouse. Same thing if you have an MES system, which is an operating system, or same thing if you have Salesforce. You want to replicate these systems because they're optimized for the kinds of data they collect, but you would want to pull down the relevant information that you need to solve the analytics cases that you have at hand. ML Flow allows you to set up that infrastructure, but it also allows you to manage these models that you've taken from your foundational library and turned them into inference models. It allows you to manage all those because over time, the inference model you deploy into production will experience data drift. That means the model will not be as accurate as when you first put it in. And eventually that model will get to the point where you have to replace it with a brand new model. And then you have to archive that original model, so there's traceability. All that is part of this ML flow or model lifecycle management. So any questions? Kubeflow does some interesting things around that as well. It does add a little bit more AI components. Would be
Jody?
machine learning. Oh, I'm sorry. Go ahead.
Hey,
Yeah, go ahead. Was there a question?
Oh, could have just been some interference.
Oh, okay, that's fine. So this is bare metal. Now let me talk about the virtualized one. Very, very similar. The piece that you'll see different here is now you have a layer of VMware components. And if your customer is already a VMware customer, then this solution integrates very nicely with that. However, you would need vSphere 8 and Tanzu to be part of what they already have. In addition, you need the VMware Tanzu service installer. So again, you can integrate with what they've already done. However, you need some additional components. And all these components for VMware are optimized for interacting with the software that's NVIDIA AI Enterprise and interacting with both the hardware, which would be the accelerators such as the L40S and our 675 V3 appliance. So any questions about those two? Because this is what they would get if they so chose to purchase the solution.
So one question from my side, is this solution available right now?
Yes, it is. Now, I'm gonna do a caveat to that. I am working as we speak, and it takes some time to get a SKU for the entire solution. So if you had a customer and you worked it out and they wanted this, then we would build the bill of materials, we get all that, but it wouldn't be under a single SKU. I want to get to the point where there's a single SKU that encompasses every bit of this, but this requires a lot of interaction with a lot of different levels of our organization to get that to happen. Now, the other point that I want to emphasize again that I've said several times now is it would be with the L40S because of the long delivery times for the H100 NVL. All right. Now then, let me give some examples of actually what you would get from a hardware standpoint. And this is talking about more from a bill of materials perspective. So this example is for bare metal, and it's talking about a mid-range. So it's looking at the 675 V3 using NDR 200. You could also do NDR 400 if you would like. It has two 960 gigabyte NVMe SSDs. It has two AMD 9554 processors. I want to talk a little bit about AMD. This solution is built on AMD because AMD is a little bit ahead of Intel in the sense that the way they've set up their processors using P-Link and using two different types of capabilities is that it improves the overall I/O. So that's the reason the preference is to use an AMD processor instead of Intel. You get NVIDIA, this says H100 NVL. Of course, that can easily be replaced with the L40S. The Connect X70s, Connect X7s are what's important to use, as well as using PCIe infrastructure to support everything that we're talking about. And then I already talked about the difference between REMA and there's some additional things that you can add based upon whether it uses Ethernet or InfiniBand. InfiniBand, if at all possible, that's going to be the best option from performance standpoint. Then you can add to this additional storage if you like. And then you can actually build out this data lakehouse that I was talking about a second ago. But all that is optional. Similar kind
So
of
Rob,
thing with.
sorry,
Yeah.
I did have one question on that one. So any particular AMD series that you on that
Yeah,
solution?
I'll show that in just 1 second.
Okay,
So
thanks.
hold me to that in just 1 second. Very similar this time for VMware. You'll notice that there's a little bit different in the setup of the sizing here is set up a little bit differently. The connectors are the same kind of connectors. You have, in this case, it's based upon Ethernet, but you could have used InfiniBand if you want. I'm going to jump to your question real fast, but I have another slide. Is it EPYC 9634? And then there's a little bit better slide that talks about that in just a second when I show the actual small, medium, and large t-shirts. Okay, so Genoa is the code name for the CPUs, and in this case, this infrastructure is for bare metal. There's going to be one similar for VMware in a second. The PCIe switches is what I mentioned before. There's some unique things around that you want to use. Connect X7s, the PCIe switches. Then everything can be connected to your InfiniBand fabric, or you could replace the InfiniBand fabric with Ethernet if you so chose. I was talking a little bit before about why AMD, and it's because of these I/O links, G-Link and P-Link. Both of those improve the I/O. They improve the cache coherency as well. Here shows the actual hardware itself. It can come in an 8X or a 4X, depending upon your use case, your price point, all those kinds of things. Here is the bare metal. It shows the difference between an entry level, which would be the 4-node configuration, all the way up to a large implementation, which is 16-node. Basically, the takeaway here is everything's very similar and very modular. So for each of these nodes, it has that software stack that I was telling you about before. Each of them has it. Then how you connect it to the appropriate switches is provided here. We have a BOM that I can provide you for each of these 3 t-shirts for bare metal. The takeaway is that as you increase the number of switches, and you increase, of course, the number of nodes. This is a similar thing. This time it's for VMware. Again, it's small, medium, and large. Again, the big difference is the number of nodes. The switches, again, stay consistent between the small, medium, and large. It's really just a matter of how many nodes you have. And the other thing, this is based on Ethernet. It could be replaced by InfiniBand if you want. But if you're using Ethernet, then you actually have 3 different speeds. One is 1 gigabyte per second. That's the yellow. The red is 200 gigabytes per second. And then the blue is 25 gigabytes per second. So there's a little bit differences between the things about how you connect them, but in general, they're highly similar. So did that answer your questions? And are there any more questions? Okay.
I don't see any additional questions in the chat.
All right. So let me generalize this. So you can start with an entry level solution with a set of appliances. In this case, I'm representing the bare metal one. And then all you have to do, because everything's modular, is adding more and more nodes. That's all you're doing as you expand. So if your customer has a use case and they want to tip their toe into this area, then they can start out at a more modestly priced solution. And then as they grow and their needs become more complex, then all they have to do is plug additional pieces of nodes into this. And of course, you would buy additional NVIDIA AI Enterprise as well. This is for InfiniBand. Ethernet is very much analogous. Okay, so are there any questions or anything that you would like to see again, or anything you would like me to elaborate on, or anything like that?
No, I think probably once everything is done here, if you can share the slides, I will make sure that the audience gets it. I think that was the big ask, because I see a couple different comments come into the chat about it. So definitely, very informative information what you provided there. Definitely interesting. Thank you.
Okay, that sounds good. I wanted to look at the chat real fast. Carl, did I answer your question about the AMD series?
Yep, about the Genoa.
Yep.
Yep.
The deck. Okay. Okay, the deck. I see that everybody. Okay. What resources could you use to arm yourself to provide the relevant guidance to your clients? Okay. This one is an interesting one, and this is the one for the next 6 to 9 months I'm working on with some colleagues. What I have learned within Lenovo, so I'm just going to talk about Lenovo, is that our sales community, is very good at selling hardware. That's our core capability. And so when we crossed into the analytics realm, which is a completely different animal, there's a lot of confusion about what it is and how it is used and how can I sell into this community. And so there's a series of collateral that we have a small tiger team that's been established, that with our sales team, with a subset of our sales team, where we're trying to figure out the best collateral to put into a sales toolkit. And this sales toolkit will consist of something like this PowerPoint, but it also will consist of things such as an executive summary. It probably will consist of a template email that you would want to send out to a community of your customers. It also will consist of how you get access to this lab hardware we're talking about, or how do you get loaner hardware. So all those kinds of things that I mentioned in the presentation will become part of this sales kit. And this is something that as it matures, we can certainly release it at large. If there are some customers that you have that are just really, really interested, and it's something that I can help you with before we have all this vetted, I certainly am willing to do that, because I realize that for the most part, this is a very different animal than people have been used to. The other thing that I want to make a distinction about from a sales perspective is traditionally hardware has been sold to IT departments. It may be the CIO, maybe the CTO has the purse strings, and of course they know hardware, they know their own infrastructure and all that. What's changed when you add this analytic piece to it is who's paying for things and the decision makers. So there's actually more personas involved. One still is IT, because they're going to have to implement whatever you purchase. But really, it becomes more important to start talking to people that are over operations, people that own the data. So they could be the chief data officer, people that own the analytics, which could be, depending upon the company, it could be the chief data scientist, or it could be, again, the chief data officer may also own the analytics. So there are these other personas that you have to reach out and reach out, hopefully, with all three of these personas being communicated concurrently. So that's the big change as well. Um, the other thing, and this is the reason I belabored the point quite a bit on use cases, is trying to get a conversation, a deeper conversation with these personas, in your initial calls becomes important, and looking for these key words to guide you down the path of, is this really a large language model? Is this just AI? Is this machine learning, or is this computer vision? Some of the use cases I provided hopefully will give you an idea of the kinds of things to ask about the problems they're having to see if the use cases make sense. So that's where I would go from that perspective.
Perfect. Yep. Thank you so much, Rob. I really appreciate your time.
Sure. Well,
Yeah,
listen,
I
guys,
believe-
thank you so much for joining. I appreciate it. And I will wrap up this deck and we'll send it out to you.
Perfect. Thank you.
All right.
Everyone, have a great Tuesday. Goodbye
Bye-bye.
for now.